Good afternoon. I am here to talk about not a single discovery that I've made, but rather the method that I use to find every discovery that I've made. And it's simply that I fail a lot. I learned a long time ago that success doesn't always teach you what failure can. And while failure is unfun, the lessons it provides are often invaluable. And I'm here to try and persuade you that pursuing failure is in this institution's best interest, as well as in the best interests of those we serve. Because every time we learn something from a failure, it becomes a success. And the faster we fail, the faster we learn. And the faster we learn, the faster we can get on to doing the good that we want to do, the good we can do, the good we must do. I'll explain how in a bit, and explain why failing fast is almost always better than failing slow. So let's look at a product, and let's put its life on a timeline. And over here, this product is a prototype. It's one of a dozen or maybe 100 ideas that have made it to this stage, which is to say that it's an idea given form. Finding out that this thing over here won't work is cheap. This is failing fast. And look over here. This thing is now a product. It has a factory, it has a trained workforce, it has a logistic supply chain, it has sales teams overhead. Finding out that this won't work over here is failing slow, and it's incredibly expensive. Now, I don't want to mislead you and say that the path from this prototype to this product is a straight line. In fact, it looks more like this. And the reason it looks like this is when we make a thing and introduce it to the world and we look at it from 100 different angles, we learn a couple of things if we're lucky. The first thing we almost always learn is this won't work. It's a failure. But if we're lucky, we learn a second thing, which is it'll teach us something about the way in which this will work. Let's look at medicine through the same lens. And over here we have the thousands of hours that doctors, researchers, nurses, support staff put in learning and honing their craft. And over here, we have patients on operating tables. We have children receiving care in emergency rooms. One misstep here can be devastating. Someone shared with me a quote recently that says, the hardest thing about being a doctor is that you learn best from your mistakes made on living people. But I'm here to ask the question of what if? What if there's a way to move any of these lessons from the high-stakes right to the low-cost left, an inch, a foot, a mile? Is it worth pursuing? Failing faster really means succeeding sooner. And succeeding sooner in medicine means best outcomes. So what is this design that I'm proposing will get us to where we want to go? Aren't designers just people that make things look pretty? Ideally, design is a process of creating a useful, usable, and desirable thing that people will interact with. What that thing is largely dependent on the type of design or designer you're talking to or about. For example, a visual graphic designer will present and organize information. An interior designer will affect and shape space. And a product designer will give form to function. I don't want to talk about the nuances of different design specialties. What I want to talk about is what's common to each of them. It's this question of asking, what if? This is the power of design. The author of Design Methods, John Chris Jones, has been quoted as saying, designers are forever bound to treat as real that which only exists in an imagined future, and have ways to specify ways in which that foreseen thing can be made to exist. So I've been here for about a year, and I want to suggest that the people in this room are already familiar with this process. You see a sick child, you envision them well, and you use your skill and your knowledge to make that vision real. So what if? What if we could use that process you're already familiar with and use it to attack your biggest problems? Instead of just accepting them as part of your job, what if those problems didn't exist? A few of you already have. A pediatric hematologist came to us with her problem. In a best case scenario, her patients need to receive 156 needle sticks per year. So it's no wonder that these patients often develop needle phobia, and in worst case scenarios, portacasts need to be installed for ongoing care. With her help, our team was able to help her ask the question of what if it was possible for her patients to have fun while at clinic. And we proposed an unorthodox solution, which was a fully immersive virtual reality experience designed specifically for this patient population to distract them from the needle in their arm and bring them into a world where they have to catch monkeys, run from pirates, and save baby penguins. Now, this unique virtual reality gameplay was built in-house here specifically for this population. And the interesting thing about it is all of the mechanics are controlled from the neck up, leaving hands and arms free to receive medication. My role in this project was to design this headset that supported this unique game design. This is the 13th version of this headset. And what I learned from the 12 versions that came before it are ways that this one would work. This is what failing fast looks like. This is what learning quickly looks like. This is how we get to a useful, usable, and desirable device quickly. This is how we achieve distraction, and we're optimistic that the fear of needles will be all but forgotten. Our own Director of Research Information Systems and Innovation, my boss's boss's boss, came to us with a problem. He noticed a problem. He noticed that both clinicians and researchers alike had difficulty identifying patient cohorts aligned with their research interests. He challenged us with the question of, what if it were easy to identify potential patient cohorts? Our team answered this challenge by making a lot of prototypes. Now, we call them wireframes, but it's just they're pixels on a page. There's nothing real behind these. They look real, but what that allows us to do is take this thing that looks real, the thing that we think people want, and we put it down in front of people like you, and we ask them, do you find this useful? How would you use this? Is this even desirable? And they would tell us, no, it's not. And so we'd take it back, and we'd revamp it, and we'd try again. And after doing this loop about a dozen times, and once we talked to enough people and started getting consistent feedback, we were able to create and build a MVP, a minimal viable product, that we feel is something that is a useful, usable, and desirable tool to help people like you figure out if a patient cohort is even relevant to your research interests. A researcher and a surgeon here came to our team and asked us, is it possible to 3D print a tissue-engineered vascular graft seeding device? Well, we can and we did. But what this development did was allowed us to ask the what if question of what if we could combine this process of 3D printing one of these devices with a patient's own MRI data? And the answer is we can envision a world in which we can take your MRI data, custom make a 3D model that we can then print and enclose in a device that's sterilized and shipped to an operating room near you anywhere in the world inside of 48 hours. So I want to take a second here and walk you through what exactly this what if process looks like. What if? Many of you are familiar with the see one, do one, teach one mantra that, mantra that surgeons learn under. What if that was different? What would it change if that could be different? What if experience was less expensive? This is a 3D stereoscopic 4K video camera. It shoots an entire space in a very high resolution in stereoscopic, so from 2 camera angles, so it's in 3D space. What if we were to take an operating room and set up an array of these cameras? What would that do? What could that do? What if we were able to replay any procedure recorded under such an array to anyone with a smartphone and a little bit of cardboard? What would it mean if today's procedure could be viewed tomorrow in India? What would it mean if we could take a surgical procedure and have an annotation layer not unlike a documentary commentary on a DVD? What would it mean if we had another layer that we could overlay in there that tells you which step of the 307 this surgeon is currently performing? The answer to all these questions is I don't know, but I'm willing to fail fast and find out. Our team has been able to help a large number of people just like you help envision a solution to their problems. And I wish I had time to share them all with you, but I don't. What I do have time for is to tell you that your problems have tremendous value because they are where your discovery can begin. And if you're willing to ask a bunch of what-if questions and fail fast, together we can treat as real that which doesn't exist, a solution to your problem. Now, if this notion appeals to you, here's a practical first step. Find the thing that bothers you most about your job. Find the thing that gets in your way and give it a name. Don't edit it, don't solve it, don't overthink it, just identify it. You then have an open invitation to come sit down with our team. And we can even come to you, we know you're busy. And together, we'll ask a bunch of what-if questions. I cannot promise you that we'll solve your problem, but what I can promise you is that together we'll try. And finally, a word of caution for those of you that take me up on this. Once you start to be able to identify the problems around you, you will likely be unable to stop. And this new way of seeing will likely change the way you see yourself, not only as a healthcare provider, but also as a healthcare innovator. Thank you for your time.